So a numerical expression is a mathematical sentence that contains numbers and operations. And what are operations when we're talking about math? Like math operations, what are they? Kevin? Add, subtract, multiply, divide? Yeah, exactly. Those are the four math operations that we're speaking of when we're doing this, okay? So a numerical expression could be something like 6 plus 3. That's it. It's got numbers, it's got an operation. That's it. Okay? So let's talk about these operations, and let's go through some key phrases that are synonyms of these operations. For instance, with addition, there are other ways to get you to understand that you're adding 6 and 3 other than saying the word add. What are some other words or phrases that when you read them or heard them, you would know that they mean addition? Probably just need to hear one or two, and then it'll start. You'll remember. Julia? Sum, exactly. S-U-M. That's one of the key, most popular synonyms for addition. Okay? Kate? All together. I'll just put together, but yeah, that's oftentimes they're used together like that. Katie? Total, you said? Yep. I know the English oftentimes use total to mean sum. We're done? I got several more for addition. Go ahead, Anaya. Plus, yeah. Billy? Add? Yeah. Jonas? In all? Yeah, I kind of like all together. How about this? How about, let's say in my class I have 20 students. And 3 students get added to my class. I would say that I have 3 blank students than I did yesterday or something like that. Emma? 3 more than. Yeah, like, so more than is another way to represent addition. You know, it's like, oh, I have 5 more than 2. Well, that means 2 plus 5. Right? Kenley? Combined, yes. So how about this? More than. Can you think of another way to say, like, more than? Like, more. What's a synonym for more? Brett? Yeah, like greater than, too. And I'm running out of room here, but like 3 greater than 6 means to add that. If we add to a total, then that total has increased, right? So increase is another word that you'll see used for addition. So maybe you want to add that to the list. All right, let's jump to subtraction. Subtraction. Kevin, what was it? Take away, yeah. Take away. That's a take away. Pierce. Difference. Good. Since addition and subtraction are inverses of one another, sometimes our phrases are inverses of one another too. So use that to help you. Keegan? Minus, of course. Minus. Go ahead, Allie. Less than. Katie? I couldn't hear you. Left, like how many are left after? Yeah, I think that would need a little more context to it, but when I hear that, I kind of think that. All right, Dom? Deducted. That's a good one. That's the first time I've heard that today, but I like that. deducted from. Cameron? Decrease, right? We talked about increased, decreased. I'm just going to add another one here, then we're going to move on. How about like fewer than? Is that what you're going to say? Yeah. Like more than, fewer than. All right, multiplication. There are not as many. There are just, I think, 3 or 4 that we're going to use here, primarily. 3 or 4. Ronan? Product, yes. Good. Product works. Anaya? Times. Emma? Multiply by, yeah. Go ahead, Pierce. I like of. You might think, of? What do you mean by of? When do we use of? When we're multiplying by what? Not a, what type of number? Fractions. If I said, what is 3/4 of 24? You could do 3/4 times 24. That means multiplication, right? Okay, Cameron? How many? Each? I think it needs more context. Like, it could if we worded it the right way. I'm good with these. Let's go to division. A couple for division. Not as many. Billy? Divided? Jack? Quotient. Kevin? All right. How about, like, if I had a group of students, like you guys, my class, and I want to break you into groups. Think about another way to say, like, break you into groups. I am doing what? Splitting, separating, yeah, words like that. You could say split or separate. And I'm good with that list right there, guys. You might think, oh, I got another one or two. That's fine. But these are the ones that seem to appear more often than others. All right, quickly, what we're going to do here is talk about what numerical expressions look like. This will not take us long. You guys will be able to handle this pretty quickly. So I have an expression like, or a word phrase like 18 cookies separated equally among 6 friends. It's not exactly the most challenging math problem I've ever asked you to do, but it's more about writing the expression. So can you identify what math operation this is asking you to use here? And just write the expression part. I don't need you to get me the answer, just the expression part. Okay, so how would you, what math calculations would you do on a problem like this? That's what I'm asking here, okay? So what would it be? What would you say? Kenley? That's it. That's a numerical expression. And I don't need to know that that's 3, because then once you write 3, it's no longer a numerical expression. That's a numerical expression. It has to have an operation in it. All right, go ahead and fill in the next 3 for me. A couple of these you could write multiple ways. Like number 2. I'm thinking of 2 ways that I could write that. But how did you choose to write it? You only needed to find 1. Ryan? I assume that's probably the most popular, 3 times 25. And it kind of hurts me to use the X there. I'm using it for you guys right now, but that's going to go away really soon, okay? I don't ever use the X, but I just put that up there. What's another way to write that? Brett? Okay, you reverse it, okay? That's the commutative property. It flips, of course. Allie? You could do 25 plus 25 plus 25. Multiplication is just repeated addition, right? So you could have written it that way. Number 3, what's your expression here? Kenley? 2, whoop. not 25, 10. 250 plus 10. There you go. Good. And the last one. You could write this a couple of ways, too. Will? Good. I like the times fraction, 24 times a half. Or when you multiply by a half, that is the same as, Pierce? Dividing by 2. So you could say 24 divided by 2. Now, I didn't ask you to do this, but what if I said, okay, guys, I need you to simplify this numerical expression. Simplify. Do you know what I'm asking you to do when you hear that word? What do you think, if I said simplify this numerical expression, what do you think I mean? Or what would you do? Katie? Yeah, so what would you tell me the answer would be? Yeah. The direction to simplify means to put something in its simplest form. Well, I could take that one more step and say, well, that's 3. That's 75. That's 260. Okay? That's what it means to simplify. Now, I didn't want you to here, because once you simplify it, it's no longer a numerical expression. But the definition on the next page, you guys already knew it. To simplify means to put it into the simplest form. To evaluate, in the next one, and this is more for the next section, but we put it in here. To evaluate means to replace a variable with its value, and then you simplify. And then the third one, order of operations. I've got a daughter who's in 3rd grade, and she knows how to add. She knows how to subtract. She knows what multiplication and division are. Probably needs some work with it. But she has no clue what order of operations are. How would you explain that to someone that knows the operations but doesn't know what the order of operations are? Like, what does that even mean? How would you describe that to someone? Greta, what do you think? The order that you do each part. Now, would your order differ from Jonas's order? No, it shouldn't. It might, but it shouldn't, right? We follow the same order when we do that. So the order of operations is the order in which an expression must be simplified. You can just keep on writing. You can fill in that table. If you're confident that you know what they are, can remember them. Yeah, many of you have an acronym to help you remember it, or a saying that helps you remember it. So if you're saying, is that what you're talking about? Yes. Step 1, when you encounter a numerical expression and it's asking you to simplify it, you're looking for this first. You do this first, or at least attend to this first. Ronan? Yeah, if there are parentheses, your focus goes there. Okay, and we saw that from our warm-up question. All right? Without parentheses, you could have done it in or you had to do it in a specific order, but with the parentheses, then you had to go right to those parentheses first. So I'll put parentheses or grouping symbols, because sometimes we use brackets too. What comes next? Something we will not be doing for a while in here. Alex? No, they come second. This is the second step. But here's the thing with that. Parentheses in themselves are not a math operation, right? It's not like if you see parentheses, it's like, oh, that means that I do this particular step. No, it directs you to the location in which you start doing the math operations. Likewise, exponents represent repeated multiplication, right? So you're really just doing that first. But if there are exponents, we must attend to them after the parentheses. Step 3. Step 3. Lillian? Addition and subtraction is not step 3. Addition and subtraction is step 4. Yeah. Addition, subtraction. Up here, step 3 is your multiply, divide. But I need clarification here. Because what do you do when you come to a problem and there's multiplication and division? Do you always do multiplication first? Because please excuse my dear Aunt Sally, not please excuse dear my Aunt Sally. Or PEMDAS. You guys remember PEMDAS? Or we don't ever say PEDMOS, right? Does that mean we always do multiplication first? Okay. Yep. I'm going to do L, arrow R, left to right. Like you read a book, you do multiplication and division. So if division comes first, do it. It's easily the single most mistaken concept behind order of operations that I see in 7th grade. I'll get kids that just are set that multiplication has to come first. It's like, well, why'd you do that division? Because it came first. Well, you always do multiplication before division, don't you? No. Okay. That's one of the problems with the acronym like we have it. We think that it has to be true like that. Okay? Yes, Ryan? Well, brackets are a form of parentheses or grouping symbols. So yeah, brackets, you go there first. And we're going to see sometimes you have parentheses inside of parentheses or brackets inside of parentheses or vice versa. Yeah, you go to the innermost set of parentheses and work your way outward. We'll see that in a second. So let's take a look down here. Let's skip example 1. Let's go right to example 2. I know you guys can do example 1. I want to show you guys what type of work I expect to come back from you. I don't want you doing this stuff in your head. You're not going to impress me if you say, hey, Mr. Lux, I just did all that in my head. See, I didn't have to show any work. That doesn't impress me. I want to see the work. I need to see the work. Okay? It doesn't take long, and it will help you think through this. So on number 2, if we follow these order of operations, what's the first math step that you're going to have to do? The first thing that you do in this problem. Greta. The innermost parentheses. So you have brackets, and inside there we have parentheses. So we start from that, and we do 6 minus 2. Now here's how I would recommend you show the work. Pick whatever step comes first, and I do that step. 6 minus 2, Greta? It is what? I'm putting you on the spot with some quick math here, right? So then I'm going to rewrite. I'm going to go 3, brackets, 6, plus. I don't need those parentheses anymore because I've already simplified that step. Now what? Kenley? 6 plus 4, 10. What does this mean? Caroline? Yeah, that means 3 times whatever quantity's inside. Now, if you want to do that with a dot, that would work. You could do it with the brackets the way they are. That still means multiplication. You could do it with parentheses. You could do it with the x, for today at least. Okay? And then you get 3 times 10 is 30. All right? So I would expect to see the steps, because we're going to do some that have 5 and 6 and 10 steps maybe. You're not going to do all that in your head. Put it down on paper. I still do it on paper. You'll avoid a lot of mistakes if you do that. Brett? Because when we introduce variables, the variable x, we would mistake them. We're going to see that. Okay. Question 3. Go ahead and give that a shot on your own there. If you get number 3 done and you're just sitting there waiting, go ahead and give number 4 a shot.
I like how you did that. Yeah. Yeah, because and I'll say this in a little while, but when you have a numerator and a denominator, it's almost like they're in their own separate brackets. So you'd simplify there, and then the last step would be to divide, just like you did.
The first question, actually the third, number 3. The thing about a problem like this that involves a fraction, numerator, denominator, that requires simplification on both numerator and denominator, it's as if you would treat these like they have brackets around them, which means you would simplify the numerator by itself separately, simplify the denominator by itself separately, and then you would perform the very last operation, which would be what on this problem? What would the very last operation be? Brett? Division. That fraction bar means to divide. So when I was walking around, I saw some mistakes because I think people were dividing in the middle somewhere. Okay? What we want to do is simplify the numerator. What does that numerator come out to equal if you follow the order of operations to get that simplification? Julia? 9. Yes, you have 6 divided by 2 is 3. 12 times 3 is 4. Either order. 12 minus 3 is 9. What about the denominator? Allie? 9. So we're left with 9 over 9, which is 9 divided by 9, which is 0. I saw 0 from like 5 people in my other class. I'm like, whoa, 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 hold up. What? 9 divided by 9 is 0 now? All right. No, it is 1. So the second one, number 4. I saw a lot of answers here. I'm going to disappoint a lot of people. 6 is not the right answer. Okay? 6 is the most common answer, but it's not the right answer. What do you think it is, Caroline? 96 is right. Very good. Anybody else get 96 besides Caroline? A few of you did. Some of you are lying, but that's fine. Okay. Good. 96. Let's talk about this. Caroline, you want to talk us through how you did it, please? Hold on. Let me catch up with you. Sorry, Caroline. Let me catch up. That's all right. I'm just going to rewrite here. So you did the 16, then you did 16 divided by 2, right? Which is 8, you said? Right? And then you did, yep. And then we talked about how this means multiplication. So 3 times 32, 96. The mistake is right there. Because you think, oh, wow, look, I've got parentheses. I've got to do these parentheses. What are these parentheses? Why are these parentheses there? They're just to show you multiplication. Yeah, they're not there to, there's no operation inside of those parentheses that needs to be done. All it's doing is showing you multiplication. So Caroline was right, and those of you that got it right, you're just going left to right here. It's just division and multiplication. That's a super common mistake, and I put that on there intentionally just to try to highlight that. So you just be aware of that as you're doing these problems. All right, let's try one more. Flip it over. I think it's down here. This will be a good one to finish on right here.
That's all correct. You just subtract 15 minus 6. We'll get everything else right now. Let's see. We got 8 minus 4 should be 4. You did 8 divided by 4. Yeah. Did you get it? Did you get it, Owen? Got it. Good. 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 Did you get a camera? That's right, Don. Good.
This one's been way more successful than the previous one. Let's get it. Good. All right, what does this expression simplify to be? Cameron? 9 is the right answer. Let's talk through this as we finish this up. Cameron, you want to tell us the order in which you did it? And that's fine. Yeah, you can get away with sometimes combining 2 and 1. So what she's saying is she did 12 minus 9 and 8 minus 4. So that's like that. Okay, then what? Very good. Okay. Now, if you did 15, then wrote minus 24 divided by 4, and then went over, that's good. That's probably even better. I'm just kind of going quickly because we're almost out of time here. So tonight, your homework, if you take a look up here, those of you that haven't seen it, remember I told you it was like the warm-up, the bell ringer? You have numbers 1 through 9. Your job is to make this equal 100. So I would like the goal to be 5. I would like you to try to come up with 5 different ways to get to 100. If you can't get 5, that's okay. Push yourself. Don't be like, oh, I couldn't get any. You can get something, all right? But same rules apply. Order stays the same. You can combine numbers, like you could make this 12 or 123. You can use any or all of the operations, parentheses, brackets, whatever you have to use, but every one should equal 100 when you're done. Okay, push yourself to try to get 5. Get more if you want. I put the worksheets on the back behind where Billy's sitting there. If you didn't get one, you can grab one. That's a question that